Hi everyone! Now, let us use the remainder theorem in solving for the remainder when we divide f of x here being 8x to the power of 5 plus 7x squared minus 3 by our divisor, which is a binomial, g of x is equal to 2x minus 1. In solving for the remainder, we just need to determine the correct c from our divisor that can be substituted in our dividend. And according to the remainder theorem, after substituting such c, whatever is the result, that is automatically the remainder when the dividend is divided by its corresponding divisor. So let's rewrite it here. Our dividend, f of x, is equal to 8x to the power of 5 plus 7x squared minus 3. This is to be divided by g of x, given as 2x minus 1. Of course, you could always use your synthetic division in solving for the remainder, which of course you could also solve for the quotient. But if the goal is just remainder, you can just simply use this process. At the same time, if you are going to use synthetic division, please acknowledge that in our dividend, the highest degree is 5, but we don't have x to the power of 4, we don't have x cubed, we also don't have x terms. In using synthetic division, you really need to include 0x to the power of 4, 0x cubed, and 0x as part of your coefficients, because if you will not do that, your answers would be incorrect. So again, we will be using here the remainder theorem in looking for the correct c coefficient that we are going to substitute in our dividend. It is actually patterned in this manner, x minus c. But the c here is not negative 1 or 1. It's because the structure should be x minus c. Here, we still have a coefficient of 2. What we need to do here is to divide both terms by 2, and therefore, you will have this form. You will have 2x divided by 2 is simply x, and minus 1 half. Since our operation is subtraction similar to our structure, automatically c is given as 1 half. Not minus 1 half, but simply 1 half, because it's x minus c and x minus 1 half. This is now the value of your c to be substituted in your dividend. And when you're going to solve for remainder theorem, no need to add terms for x to the power of 4, x cubed, and x. Simply substitute your c in as the value of your variable. Just like this, you have your plus 7, you have 1 half, but you need to square that, and minus 3. So here, PEMDAS, let's start with our exponentiation. The fifth power of 1 is 1. The fifth power of 2 is 32. You have here plus 7 times, you have 1/4 as the square of 1 half, and minus 3. Take note that you can divide this by 8, because 8 times 1, 8 times 4, you still have 4 here, which would give us a result of 1/4. Next, plus, since 7 can be written as 7 over 1, multiply numerators. 7 times 1 is 7, over 1 times 4, which is 4. And then minus 3. You will have here 1/4 plus 7/4 is 8/4, or simply 2 minus 3. Therefore, your remainder, according to the remainder theorem, is negative 1. This is now the remainder, even without using synthetic division. But of course, you could always verify this by using the synthetic division in solving for the quotient at the same time as the remainder when dividing f of x by g of x. Take note, we used here the correct c. It's not just any c, but the c taken from your divisor. That's all for today. You're dismissed. And please do not forget to subscribe now.